Okay, a little different listening pleasure today.
Spent $48 last night at the county fair. I throwed up my shoulder, but I want her that teddy bear. She's got me saying sugar pie, honey, darling, and dear. I ain't seen the Braves play a game all year. I'm gonna get fired if I don't get some sleep. My long lost buddies say I'm getting in too deep, but I like it, I love it, I want some more of it. I try so hard, I can't rise above it. Don't know what it is about that little gal's loving, but I like it, I love it, I want some more of it. Mama and Daddy tried to teach me courtesy, but it never.
All right, a little country music for those country fans out there. Hey, so yeah, I didn't get any questions on the question document. So well, I guess that means I'm gonna just move along here. I'm still waiting on quizzes too, by the way. So you need to get those taken care of. All right, so make sure that you get those things done. I just don't know what to say about it other than you just need to get them done. So it's the ones I turned in were really good, and I mean this is something that's going to take you 6 minutes to do, maybe more, not much more. You should be able to just do it. Enough said about that. Again, put your questions in the question document so I can help you out. Okay. Here's what we're going to do. We're going to keep talking about radicals a little bit here. And what the topic on the radicals is just going to be some simplifying and maybe just taking a peek at multiplication. All right. I don't know how much simplifying that you've actually done with radicals. We don't spend a lot of time on that. It does kind of come up in geometry, but not a whole lot. I don't know how much the Algebra 1 teachers, I kind of talked to them a little bit. So we're thinking that some of this is going to be a little bit new to you, but we'll kind of go along and see what happens. So first of all, there's a difference between simplifying a radical and evaluating one. So for example, let's say I put down the square root of 40 down here, okay? And the problem is that we're going to simplify it. What happens a lot of time is students will just say, oh, okay, I'm just going to use Desmos or whatever calculator I got, take square root of 40 and get an answer. Well, that's not what this is asking you to do. What this is asking you to do is to put it in a simplified form. And so what we're really after is an exact answer. All right, when you put that into a calculator, you're going to get a decimal approximation, no matter what you do. So you're going to round it off. It's not going to write every single number that goes with that. So every single digit. So that's not an exact answer. And we need an exact answer. So I'm going to show you how to simplify this. All right. Since this is a square root, what we're going to do is I'm going to make a little table over here. All right, and I'm going to put 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to go up to 12, and then I'm going to stop. This is going to be my numbers. Now, I didn't start with 1 because 1 squared is 1. So I'm hoping that you probably are okay with that. 2 squared is 4, 9, 16, 25. Most of these you probably know. I'm going to put these on here. And I'm going to stop at 12. You're probably not even going to go that high. ever, but I'll put it on there anyway. So we're going to simplify this by finding the largest perfect square. These are perfect squares because 2 squared, 3 squared, 4 squared, 5 squared. Those are called perfect squares. So we want to find the largest of those perfect squares that go into 40 evenly. So if I go down this list, all right, I'm looking for numbers that divide into 40 evenly. All right, I want the largest one. So I have 9, 16, 25, 36, 49. Of course, I'm not going to find anything in the up larger than 36 because you're just not going to find any numbers that go in there. So 4 is our obvious choice here. So I'm going to go 4, and 4 times 10 gives me that 40. All right, so I'm still got a square root here. So then what I'm going to do is take the square root of the number that I can. I can take the square root of 4. That's 2. The 2 is going to come out to the outside, and the 10 is going to stay on the inside. And that's how you simplify a square root. All right, there's a difference again between simplify and evaluate. Evaluate means you put it in a calculator and get an answer. So let's try another one here. We're still simplifying. All right, so let's try 27. All right, so 27, we're going to take the square root of that. Again, that's not a perfect square. I'm looking for the largest number that goes in there. You're probably already shouting at me. It's 9. 9 goes in there 3 times. All right, so there's that. Now I'm going to take the square root of the number that I can. I can take the square root of 9 because that's 3. So the 3 is going to come to the outside, and this 3 is going to stay on the inside. All right, so that is what that looks like. Okay, I'm going to keep going here and keep doing some more simplifying. All right, let's go with 80. All right, so now I want to simplify 80. So I want to find the largest perfect square. I bet that the number that comes to mind for you is 8. Problem is, 8's not a perfect square. All right, if I look down the line, I see 4, I see 9, I see 16, and 25. I do not see 8. 8 is not a perfect square. It's got to be the numbers that are in this column right here. All right, it's got to be these numbers. Those are your perfect squares. So we see 4 goes in there. You're right. 4 goes in there 20 times. But we want to make sure it's the largest. And we know 9 doesn't. But we might want to try 16. All right, so let's see if 16 goes into 80. I'm going to use my calculator. And I'm going to take 80 and I'm dividing it by 16 to see if 16 goes in there evenly, and it does. 16 goes in there 5 times. See, we want to find the largest, okay? Because if you don't, then you're just going to have to simplify again. So you want to find the largest. So now we're going to go ahead and take the square root of 16. Well, the square root of 16 is 4. So the 4 drops on the outside. The 5 stays on the inside. And again, that's how you're simplifying. These are square roots that we're working with here. Okay, scooting this up. Some more. Let's see. Let's do 72. All right, 72 is another good example because if you look at all the perfect squares that go into 72, the first thing you probably think of is 9. All right, 9 goes in there 8 times. But is it possible we can find a larger one? All right, so we're going to see 9, 16, 25. No, 16 might. I can go ahead and divide that and see. So if I take 72, divide that by 16, I get 4.5. No, that's no good. All right, what about 36? 36 goes in there. Ah, there we go. 36 goes in there 2 times. All right, so now I take the square root of 36 because I can. That pops on the outside. The 2 stays on the inside. So what would have happened? What would have happened if we didn't find 36 and we said, I'm going to go with 9 and I'm going to go with 8. All right, because after all, 9 is a perfect square. So if we square root the 9, because we can, that's a 3, right? And the 8 stays inside. The thing is 8 is still able to break down, because you can take that and put a 4 goes in there. 4 goes in there. I don't know why I'm not, there it goes. 4 times 2, all right? So, and I can take the square root of 4, which is 2, but there's already a 3 out there. So then that's going to become 6 square roots of 2. So you see, it's better to find that largest perfect square rather than just going with the first one you see, because then you might have to do it twice. All right. Does it get a little more complicated than this? Well, yeah, sure, you know that, because it's mathematics and algebra 2, and it's going to get a little more complicated. What if we have something like this? Let's say that we have, let's go with 32x to the 4th. What if we have a variable in there? All right, what does that mean? Well, we're still going to break down to 32, right? So I got to find the largest perfect square that goes into 32. So I'm going to go down my list. See, 4, I know 4 does, right? 4, 9, 16. Oh, 16 goes in there. 16 times 2. Square root of 16 is 4. All right, then I have the square root of x to the 4th. Now, how does that work? Let's write this out. All right. Okay. Since this is a square root, then there's really a 2 there. We never just write it. This 2 will take out these 2 and also these 2 because it's a square root. So basically, we're taking out 2 pairs of x's, all right? And that leaves us with an x squared, okay? So that's one way of looking at this. And that 2 stays. All right, there's another way of looking at this. All right, so we're still going to think about this 2 because it's a square root. 2 goes into 4 2 times, and there's nothing left over. So that means I'm going to have an x squared on the outside. All right? So that's how you work with variables. You can think of it in a couple of different ways. Let's take a look at another one here. All right, so let's go with the square root of, this time I'm just going to go 9x to the 3rd and y to the squared. All right, so first of all, we're lucky because the 9 is a perfect square. So the square root of 9 is 3. I don't have to worry about that. So this is a 2 here, right? So 2 goes into 3 one time. So that means I'm going to have one x come on the outside. But I have an x as a remainder, so that's going to stay on the inside. All right, so 2 goes into 3, 1. Goes in there once, so I bring out one of those x's, leaves me with 1. That stays inside. Y squared, square root of that is just going to be a y, and there's my answer right there. Kind of crazy, but that's how it works. All right. I'm not convinced that you know how to do one of those yet, so let's try one more. Come on, we got one more in us. Let's do it. Here we go. Let's go with 54. All right, x to the 6th and y to the 7th. All right, so that's a 7 right there. Let me just clean that up just a tad bit. Oh, look at that. The whole darn thing went away. There we go. And this is a 7. Okay. So let's do this. So now we got to go up to our chart, right? We got to find the largest perfect square that goes into 54. Okay, going down the chart, 4, maybe. Let me see, 54 divided by 4 equals, no way, it doesn't fit. 9, well I know 9 and 6 do, All right, so 9 might be the winner. So then I have 16. Nah, I don't think 16 goes in there. I mean, you can try it, but I don't think it does. And then we'd have 25, obviously not. 36, I think we're getting too big now. So 9 and 6 have got to be our answers. Okay, 9 and 6. All right, so now that we know what our perfect square is, we can continue to do this. So let's see. I can take the square root of 9, so that's going to come to the outside. All right. Now I'm going to do, again, this is a 2, so 2 goes into 6 3 times. So that means we're going to have x to the third on the outside. 2 goes into 7 3 times, but there's 1 left over. So that would be y to the third. And then inside the square root, I'm going to still have that 6 and one of these y's, right, from the leftovers. That's what that looks like. Okay, so again, this is a 2. 2 goes into 6. I'm only interested in the powers. Goes into the 6 3 times. That's why I have x to the third out there. 2 goes into 7 3 times. There's your 3 with 1 left over. All right, that's the best way to think about those, is to just think of it in terms of your square root. Okay. Let's see. I don't know if I want to really do some multiplication. Let's do one of these, though. All right, I'm going to change colors for a second to different. And I'm going to go over here and write another chart. This one, though, I am going to start at 1, don't know why, but this is going to be 2, 3, 4, 5. This time I'm going to talk about cubes. All right, so 8, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. So cube roots can also be simplified using the same strategy but different numbers. So if we have the cube root, it'll have a little 3 right there. Let's say we're going to go with 16, right? X to the fourth. All right, so how is that going to work? Well, we're going to check these numbers over here on the side now, right? And see which one of these will evenly go into 16. Well, obviously 1 does, but that's not going to get us anywhere. 8 does, and that's the only one. So we have 8. All right, so we have 8 times 2. There we go. So now I'm going to scoot this up a little bit. So I have 8 times 2. So the cube root of 8 is 2. So the 2 comes to the outside. Now this is a 3. We're going to use the same strategy. 3 goes into 4 once with 1 left over. So that means I'm going to have this 2 and one of those x's left over. And that is a cube root. All right, so it's the same idea as a square root, but different situation. Okay. So I think what I'm going to do is just give you a couple on simplifying. All right, and then next week, Monday morning, we'll start out by doing some multiplication of square roots, and also multiplication's it's pretty gives us a pretty broad topic to work on. So this would be pretty good just to simplify, and I think get you used to doing that. So let's do that. Anyway, hey, have a great little weekend.